Hello, my name is Andrew Pelletier. I work for NSK Bearings, and I'm here on behalf of the Bearing Specialist Association to present a training on unmounted roller bearings. The materials that we're going to discuss today are provided by NSK and NACHI. In this first slide, you can see a pictorial description of a number of different types of roller bearings that we'll discuss today, from cylindrical, spherical, and taper roller bearings. The three main types, as discussed, are defined generally by the type of the roller shape. As you can see, the cylindrical, as is noted, is a cylindrical type shape, taper, and then the spherical, or sometimes called a barrel shaped roller. The type of bearing that you will use is determined by the load, speed, misalignment, and also assembly requirements needed for your particular application. The first type we'll discuss in detail is the cylindrical roller bearing. Cylindrical roller bearings are designed to accept primarily heavy radial loads. The 6 different series of cylindrical roller bearings are shown below. For the same bore size, we have different OD and widths, which give you different load and speed capacities for your particular application. The boundary dimensions align with what you see for radial ball bearings as well. While you have different dimensional series for the cylindrical roller bearings, you also have different configurations. The most common types are the NU and the NJ type. The NU type has 2 ribs on the outer race of the bearing and none on the inner race. This type of cylindrical roller bearing cannot accept any thrust load. The next most common type, the NJ, has ribs on the outer race and a single rib on the inner race. This allows it to accept moderate amounts of thrust load in a single direction. You also see the other common types of N, NF, NU, and NP, and finally the NH with an additional collar that is added. In addition to the single rows, you also see double row and 4-row cylindrical roller bearings. In addition, you also have some types that are with full complement with no cage. Some common examples for cylindrical roller bearings and applications are motors for both electric traction motor for railroads, generators. You see them commonly used in gears, drives, fans, blowers, so a variety of industrial applications. In addition, we also see them employed with machine tool spindles as well. Those are commonly a double row type or also single row. And this is for a higher speed application than we see in the traditional industrial applications. The next type we'll discuss is the taper roller bearing. The taper roller bearing is able to accommodate loads, both radial and axial, in a combined load. And these are a separable design with a separate cup and cone. We'll show the details of the assembly of the taper roller bearing in coming slides. This particular type also has adjustable preloads, is available in precision assemblies, and from a assembly standpoint is a bit more complex than a standard deep groove ball bearing. As we saw with the cylindrical roller bearing, the taper roller bearing is very good for heavy radial loads, but it's also quite good for very strong axial loads as well, but in a single direction only. You'll commonly see as we look into future slides that we'll see how they accommodate thrust loads or axial loads in multiple directions. A benefit of the taper roller bearing is that it provides true rolling motion and low friction. For the cage, this is commonly used with a pressed or stamped steel, and a pin type cage is often employed in larger bearings where a pin is put through the bore of the rolling element to provide additional capacity. Similar to the cylindrical roller bearings, the taper roller bearings are available in single, double, and 4-row designs. Next, we're going to look at the components. You will oftentimes hear the taper roller bearings referred to as the cup or the outer ring of the bearing, the cage, which will separate the rolling elements and provide guidance to the rolling elements, and finally the cone, or the inner ring of the particular bearing. You can see again here where the rollers for this particular type of bearing do have this taper shape from one end to the other, thus giving it their name. For the ability to take load in more than one direction, or a axial load in more than one direction, we commonly use these bearings in two bearings together on a single shaft, or a double row type bearing. In this example, we see the DB, or back to back, and the DF, face to face. And for your particular application, that provides benefits of whether it provides additional rigidity or may offer some misalignment capability. The single row bearings have individual spacers between the cup and cone where you can adjust the preload or the bench end play or clearance of the particular unit. On the double row type bearings, we have commonly the TDO or the TDI. In this example, you see for the TDO, you have a double cup and single cones. On the TDI, it is the exact opposite with the double cone and individual cups. Again, the selection is based on your particular application. Some common examples, again, we see very commonly used in construction equipment, cone crushers, gearbox, steel rolling mills. And this is where we see the benefit of the very high load capacity of the taper roller bearing in both the radial and axial load being employed for that particular application. Moving on, we'll next discuss the spherical roller bearing. Again, the spherical roller bearing is so named by the shape of the rolling element, and sometimes you will hear people call that a barrel roller or spherical roller shape. This is a very common workhorse of the industry. The spherical roller bearing allows up to 2 degrees of misalignment with no reduction in bearing life. We see that the spherical roller bearing has a very high radial load capacity, and it can also take some axial load in either direction. This is very good for shaft deflection, and it can accommodate shock loading as well. The spherical roller bearings are available both in a cylindrical and taper bore for your particular application needs. They're commonly seen with a brass style cage for the larger size bearings, and then steel cage options for medium to smaller size range. Similar to what we see with the other bearings, the spherical roller bearings are available in a variety of dimensional series with different bore and OD and widths as needed for your particular application, giving more load capacity or speed for the particular need. Looking at the assembly, we see the bore, OD, and then rollers, always a double row of rollers for this particular application. With the brass cage, we see sometimes you will see a guide ring here to support the cage. And then in the steel type, you're commonly seeing this in a more high capacity style design because you're able to fit maybe 1 to 2 additional rollers per bearing to give additional capacity. A common feature seen on most spherical roller bearings is the lubrication groove and holes in the outer race. For some applications, the bearing will have a lubrication groove and hole through the inner race as well, depending on application needs. As we discussed earlier, the spherical roller bearing is unique in that it allows up to 2 degrees of misalignment without any adverse effects. This shows what this would look like in an application, and it's exaggerated so that you can see it for clarity, showing misaligned housings, shaft bending, or dynamic vibration. This is commonly what you would see in a vibratory screen or shaker screen, and we have special series of bearings and suffix for this particular application. Some common examples for spherical roller bearings: steel mill continuous casters, where the misalignment capabilities and heavy load are well suited. Commonly, they're used in gearboxes, aggregate equipment, and also in mounted bearing units where they're put into a plumber block or SAF type block to support the bearing and allow it for easy mounting. Showing some additional examples here from an application standpoint, you can see in gearboxes how all the roller bearing types that we've discussed today can be used in the gearbox, from the spherical, the taper, or the cylindrical roller bearing, depending on the type of gearbox, the loads it's seeing, and also the type of gearing that you are using in your particular gearbox. Some additional examples: you see the spherical roller bearings used in construction equipment, but we also have showing the different of a spherical thrust bearing instead of the radial type bearing, using this for very heavy loads in rotating environments. And then also the double row cylindrical roller sheave bearing shown here. This is commonly a application where we see it without the cage in a full complement style for very heavy loads as well. Thank you for your time.